Hey everyone, ready for a deep dive into some seriously cool stuff? We're tackling two pretty different worlds today. First, we've got the rumored Tesla PiPhone going head-to-head with the iPhone.
Yeah, and then we're going to jump into the Large Hadron Collider at CERN, talk about a wild mix.
Seriously, it's like we're going from cutting-edge tech to the mysteries of the universe all in one go.
Exactly. I mean, on one hand, we've got this potential shakeup in the smartphone market, a world shaper. Apple's basically ruled for, over a decade now?
Right, and then we're diving into, the fabric of reality with the LHC.
It really shows you how much we're pushing boundaries these days, both in technology and in science.
So let's start with this tech showdown. I've been seeing all this buzz about the PiPhone, and I gotta admit, even I'm kind of getting swept up in it.
Totally understandable. Tesla's got that it factor, They disrupted the whole car industry, so it's only natural to wonder if they can do it again with smartphones.
For sure. And some of the rumors are just wild, like a titanium body, a graphene screen, a finish that can change color. It almost sounds too good to be true, right?
Yeah, it's easy for rumors to get out of hand, but even if we're cautious, there's a lot to be excited about, especially when you consider Tesla's whole ecosystem.
That's what I keep thinking about. They're not just making a phone, they're making the control center for all things Tesla cars, solar panels, Starlink.
Right. Imagine managing your Tesla, checking your solar power, and browsing the web at crazy fast speeds, all from one device.
Wow, that's a powerful vision.
It is. And that's where Tesla could really outmaneuver Apple, even if the PiPhone specs aren't totally perfect. Apple's got a strong ecosystem, but it's mostly about personal devices.
Yeah.
Tesla's aiming bigger, trying to connect transportation, energy, and communication all together.
And don't forget about their battery tech and AI. If the PiPhone even gets close to the battery life of a Tesla, that's a game changer. Oh, absolutely. Imagine a phone that goes for days without needing a charge. That's like the holy grail of smartphones, right? And Tesla's already leading the way with batteries in their cars.
Exactly.
It's not crazy to think they could bring that to the smartphone world.
Okay, but here's what makes me a little unsure. Apple's been perfecting iOS for years. It's smooth, easy to use. It just works. Can Tesla actually make a whole new operating system that's not just functional, but enjoyable?
That's the big question, right? And it's probably Tesla's biggest hurdle. Building a new OS from the ground up is massive.
Yeah.
They'll need to get developers on board to create a whole app ecosystem. But they've shown they can attract talent and pull off ambitious stuff.
Right.
Remember how skeptical people were about Tesla's self-driving stuff? And look where they are now.
It's true. A lot of people doubted them. And you know what? I think a lot of people want an alternative to iOS and Android, especially with all the privacy and data collection worries these days. Tesla's focus on decentralization, like with Starlink, could be a huge selling point. Totally. If Tesla can make a phone that's truly secure and puts privacy first, that could set them apart, especially if they're open about how they handle data.
All right, let's get into the specifics. The PiPhone design rumors are pretty mind-blowing. Titanium body, an all-screen display with a hidden camera. Maybe even a color-changing finish using nanotech. I mean, is any of that even possible?
Well, some of it's definitely more realistic than others. Titanium is already used in some high-end phones, so that's not a stretch.
Yeah.
Hidden cameras are getting more common, and nanotech's moving fast. But a color-changing finish that's both tough and looks good, that's a challenge for sure.
Right. It's a lot to get right.
Yeah.
But even if they don't nail every futuristic feature, the PiPhone could still be a big deal, especially if they focus on what they're good at: battery life, performance, and seamless connection to their whole ecosystem.
Exactly. They don't need to reinvent the wheel. Just make a phone that's clearly better in the areas that matter.
Right.
And with Tesla's track record, I wouldn't underestimate them.
So while we wait for more solid info on the PiPhone, it's clear Tesla jumping into the smartphone game could be a real shakeup. But how about tech that's already pushing limits in a totally different way? My theme that's helping us uncover the universe's secrets.
You're talking about the Large Hadron Collider, right?
Right.
Now it's a whole other level of mind-blowing.
It is, and I know you're the perfect person to break it down for us. We're talking about smashing atoms, discovering new particles, maybe even finding evidence of parallel universes. It's enough to make your head spin.
It's definitely some mind-bending stuff, but that's what makes it so fascinating. The LHC is like a giant window into the inner workings of the universe. And with every experiment, we're learning more about where we come from, what we're made of, and what the future might hold.
All right, so last time we were talking about the LHC, and you said it was like a window into the universe. But honestly, some of the stuff I've read about it is kind of intimidating. Yeah, like we're talking about recreating Big Bang conditions, smashing atoms together at almost the speed of light. It makes you wonder, is all that even safe?
I get that a lot of people have that question. When you're dealing with forces and energies that massive, it's natural to think about what could go wrong.
Yeah.
But the thing is, the LHC has these super strict safety protocols.
So no chance of accidentally creating a black hole that like swallows the Earth. I've seen that in a few movies. Had to ask.
Huh. Yeah, makes for a good movie plot. But those scenarios are pure sci-fi.
Right.
The kind of black holes that theoretically could be made in the LHC, they'd be microscopic, gone in an instant. No danger at all.
Okay, good to know. But what about those other theories out there, like the Mandela effect, for example? Some people think the LHC is messing with reality, creating alternate timelines or something like that.
The Mandela effect is definitely interesting. The idea that a bunch of people can share the same false memory. It's weird, right? But connecting it to the LHC, that's a stretch. No scientific evidence for that. Memory's tricky. Our brains can be unreliable. The Mandela effect is probably more about how our brains work, not some physics experiment.
So no parallel universes or time travel happening at CERN.
Not that we've seen. But hey, that's what's cool about science. Always pushing the limits. Who knows what we might find?
True, true.
But those discoveries, they'll be based on real evidence, solid science, not just guesses.
Makes sense. But speaking of guesses, let's talk about some of those controversies around the LHC. Remember that video that went viral a while back, the one supposedly showing some occult ritual at CERN?
Oh yeah, the occult murder video? That was a pretty wild hoax. Hooded figures, fake blood, even CERN badges. It played on people's fears about like secret societies and science going too far.
But wasn't it actually filmed at CERN? I thought they confirmed that part.
It was filmed on CERN's grounds, yeah, but it was totally unauthorized.
Yeah.
Some people with a flair for the dramatic, I guess.
Yeah.
CERN looked into it and made it clear they had nothing to do with it, just a plain hoax.
Mystery solved then. What about that theory saying the LHC was causing earthquakes in Italy? Something about firing high-speed plasma at a lab there.
Right. That one made the rounds too.
Yeah.
Completely baseless. For one, the LHC can't fire plasma, and even if it could, there's no way it could trigger earthquakes. Pure fabrication.
Okay, and I gotta bring this one up. The time traveler theory. Some people actually thought the LHC breaking down back in 2008 was caused by a time traveler from the future trying to stop some disaster.
The time traveler theory, a classic, shows how much we love explaining the unknown with crazy ideas. In reality, the breakdown was a faulty electrical connection between magnets. Embarrassing, maybe, but no time travelers involved.
So those theories might be fun to think about, but it sounds like the real LHC story is less sensational, but still amazing.
For sure. The science happening at the LHC, it's already mind-blowing. Pushing the limits of what we know, figuring out the fundamental forces of nature, maybe even discovering things that'll change how we understand the universe forever.
Okay, so let's get into some of those discoveries. The LHC was key in confirming the Higgs boson exists, the God particle. But I'll admit I'm not totally clear on what it is or why it's so important.
It's a tough concept to wrap your head around. Basically, the Higgs boson is this tiny particle that gives other particles mass. Without it, the universe as we know it wouldn't exist. Think about it, a world where particles just zip around at the speed of light, never slowing down to form atoms or molecules or planets or stars.
Whoa.
A pretty empty place, right?
Yeah, definitely. So the Higgs boson is kind of like the glue holding everything together.
In a way, yeah. It's what allows stuff to have substance, to interact, to form all the structures we see.
Wow, that is profound, but I guess there's still a lot we don't know about it.
Tons. Finding it was huge, but it's just the start. We still need to learn about its properties, how it interacts with other particles, and maybe even how it explains some of the bigger mysteries, like dark matter and dark energy.
Dark matter and dark energy, I've heard those terms, but they always sound kind of scary. What are they exactly?
Those are two of the biggest puzzles in physics today. We know they exist because of how they affect the universe, their gravity, but we don't know what they're made of. Dark matter makes up like 85% of all the matter out there, but doesn't interact with light, so we can't see it directly.
Wow.
And dark energy is even weirder, this force that seems to be speeding up how fast the universe is expanding, but we have no clue what it is or where it comes from.
So we're talking about stuff that makes up most of the universe, but we have almost no idea what it is.
That's what's so exciting. It's like we're just starting to understand what the universe is truly made of.
Yeah.
And the LHC is one of the best tools we have for figuring it out.
It sounds like we're on the edge of some major discoveries. What are scientists hoping to learn about dark matter and dark energy using the LHC specifically?
Well, one big goal is to actually detect particles that might be part of dark matter. Lots of theories about what these particles could be, but we haven't found them yet. The LHC might be able to create them in these high-energy collisions, which would be huge.
So it's like we're trying to catch a glimpse of this invisible stuff by smashing other things together hard enough to make it appear.
Kind of, yeah. It's a super delicate process, but the payoff could be enormous. If we crack the secrets of dark matter and dark energy, it would totally change how we see the universe.
Okay, so we've got the Higgs boson, dark matter, dark energy. Sounds like the LHC is tackling the biggest questions out there. But I'm also curious about more practical stuff. How does all this research affect our everyday lives?
Good question. It's easy to focus on the big ideas, but CERN research has actually led to a bunch of advancements that have real-world uses.
Like what?
Well, for one, the World Wide Web was invented at CERN.
No way! The internet came from particle physics.
Yep. Tim Berners-Lee, a scientist at CERN, created it back in 1989 so scientists could share info easier. No clue it would become what it is today.
So we can thank particle physics for cat videos and online shopping.
You're welcome. But seriously, CERN's research has done way more than just the internet. It's helped improve medical imaging, cancer treatments, even made solar panels more efficient.
Wow, so the LHC isn't just about understanding the universe, it's about improving life here, too.
Exactly. That basic research at CERN has effects that reach way beyond the lab. It shows what can happen when people from all over work together just because they want to understand the universe better.
Okay, so we've covered a lot about the LHC, black holes and time travel, dark matter, the internet. It's been a wild ride. What about the future of this thing? What's next for the scientists working on it?
Well, like I mentioned before, the high luminosity upgrade is a big deal. Basically, they're going to make the LHC even stronger, so there are way more collisions.
So more collisions, more data, more chances for discoveries. What are they hoping to find with this upgraded LHC?
So many possibilities, but a few things stand out. One is finding particles that go beyond what we know, beyond the standard model of physics. Things like supersymmetry, dark matter particles, new types of Higgs bosons. The high luminosity LHC could give us the proof we need to say whether those theories are right or wrong.
It's like opening a whole new door into how the universe works.
Exactly. Another cool thing is studying exotic matter, stuff like quark-gluon plasma, which was around right after the Big Bang. By making those conditions in the LHC, we can understand the forces that shaped the universe into what it is today.
It's mind-blowing that we can recreate those Big Bang conditions right here on Earth.
It is. And those experiments could answer some of the biggest questions about how the universe began, how it changed, and what might happen to it eventually.
You know, it's just incredible to think that a machine like the LHC can show us secrets about the universe that have been hidden for, like, billions of years.
Right.
It's like we're looking back in time to the very beginning.
It really is amazing. And I think it all starts with these tiny particles, the fundamental building blocks of matter. We were talking about quarks and bosons and fermions. It's a whole zoo of particles down there.
I know, right? It's all so tiny, though.
Mm.
It's hard to picture how those particles, which are so small, we can't even see them make up everything, like stars and planets and even us.
Yeah, it's a question physicists have been trying to answer for a long time, and the LHC is helping us get closer. Think of it this way. Imagine a giant Lego set.
Okay.
Each piece on its own is pretty simple, but you put them together in all these different ways, and you can build these huge, complicated structures.
I like that. So the particles are like the Legos, and the universe is the thing we build with them.
Exactly. And the LHC is like our toolbox. It lets us really look at those Legos, figure out what they can do, and see how they all fit together.
Gotcha. So it's not just about discovering new particles, it's about how they work together to create all the complexity we see.
You got it. And the more we learn, the more we realize there's even more to discover.
So we've talked about what the LHV has done and what it's doing now. What about the future? What are the goals and challenges for the scientists working on this amazing machine?
Well, one of the most exciting things is the high luminosity upgrade. Like we talked about before, it's basically going to supercharge the LHC, give it way more power.
Right. So more collisions, more data, more chances for breakthroughs. So what are they hoping to find with this upgraded LHC?
There are a lot of possibilities, but a few things stand out. One is searching for those new particles we were talking about before, the ones that go beyond the standard model of physics. Things like supersymmetry, dark matter candidates, new types of Higgs bosons. The high luminosity LHC could actually prove whether those theories are true.
So we could be entering a whole new era of physics.
Exactly. We could be moving past the standard model and into totally unknown territory.
Wow. And what about studying those exotic particles, the ones from the very early universe?
Oh yeah, that's another exciting area. Stuff like quark gluon plasma. By recreating those conditions in the LHC, we can get a glimpse into what happened right after the Big Bang.
It's amazing that we can do that here on Earth.
It really is. And those experiments could help answer some of the biggest questions about the universe. How it started, how it's changing, and even what might happen to it in the end.
You know, I started this whole deep dive feeling a little skeptical, especially after reading about all those weird theories about the LHC. But now I'm honestly just amazed. It's a testament to human ingenuity and our desire to understand the universe.
I couldn't agree more. The LHC shows what we can do when people from all over the world work together because they want to learn. It's inspiring.
And even with everything we've learned so far, it feels like we're just getting started.
Absolutely. The journey of scientific discovery never really ends. There's always something new to learn, more questions to ask, and more mysteries to solve. And the LHC will be a big part of that journey. It'll keep pushing the limits of what we know and inspire people for generations to come.
Well, on that note, I think it's time to wrap up our deep dive. From the Tesla PiPhone to the mind-blowing world of the Large Hadron Collider, it's been quite a journey.
It really has.
We hope you enjoyed exploring these frontiers of technology and science with us.
And remember, curiosity is the key to understanding the universe. Keep asking questions, keep exploring, and never stop learning.
That's a wrap on another deep dive. We'll catch you next time. Keep those brains buzzing and keep diving deep.